One of the most challenging parts of performing a hypothesis test is to actually design the hypotheses appropriately. And in order to do that, the thing that you need to do is keep in mind that the null hypothesis is the hypothesis that would be rejected if the test statistic lands in the unlikely area, or what we will call the rejection region. So let's look at this first example. It says a medical researcher believes that more than 15% of the residents of a certain area have high levels of mercury in their blood. So if we were to look at a normal distribution, we would note that this particular statement has to do with a proportion. It says here a 15%, which can also be written as 0.15. And it says that this medical researcher believes that more than 15% of the residents have high levels of mercury in their blood. So we're hypothesizing something about this proportion. We're hypothesizing about whether or not it's greater than 15%. So if we have a distribution where the population proportion is 15%, we would conclude that it's not 15% in favor of it being greater than 15% if this rejection region, or this unlikely area, was all concentrated up here and we landed up here. So our unlikely area, or our rejection region, would be all up here to the right, because we really don't care what's down here to the left in this case. Because if the sample proportion is less than 15%, then there would be no sense in trying to use it to argue that the population proportion is greater than 15%. But if the sample proportion is actually greater than 15%, then we might start to think about, well, is it big enough that we would reject that the population proportion is 15% in favor of it being greater than? So our null hypothesis then would be that the population proportion is 0.15, and the alternative hypothesis would be that the population proportion is greater than 0.15. So this would be a one-tailed test. And the key here is that this wording right here, this researcher believes that more than 15%. So if we're going to conclude that more than 15% have this characteristic using a sample, then that sample would have to show that it is significantly greater than 15% in order for us to reject that the population proportion is 15%. Let's look at the next one. It says a newspaper article has claimed that the average concentration of mercury in a certain water source is 2.3 parts per billion. Okay, this time we're talking about an average, a mean. So we're hypothesizing about a mean of 2.3 parts per billion. Now we'll note that this article has claimed that the average concentration is 2.3 parts per billion. It doesn't say greater than or less than. So our unlikely area, or our rejection region, would be split out into two tails, because either much greater than or much less than 2.3 parts per billion would lead us to conclude that it is not 2.3 parts per billion. So when would we reject this assumption? If we land either to the right or to the left, where in this case, in order to draw this conclusion, more than 15%, it would all have to be concentrated to the right. So our hypotheses in this case then would be mu this time, a mean, we're working with the mean, equal to 2.3 parts per billion, and mu not equal to 2.3 parts per billion. So in this two-tailed test, the hypotheses are equals and not equals. Let's look at the next example. A psychologist is studying the effects that high levels of mercury have on brain function. He has identified a population in a region that suffers from elevated levels of mercury due to a contaminated water source. He believes that the average score for this group on a particular aptitude test will be less than the national average of 78.4. Now we need to key in on some words here. It says less than. He believes that it would be less than. So if we again think about our distribution here, we're conducting a hypothesis test about a mean average score. And the hypothesis has to do with whether or not it is less than 78.4. So this assumption then that the mean is 78.4 would be rejected in favor of this person's belief if the sample statistics fell out in such a way that we landed in this very unlikely area way over here to the left, less than 78.4, significantly less than 78.4, to allow us to reject a null hypothesis that the mean is 78.4 in favor of an alternative hypothesis that the mean is less than 78.4.